Okay, welcome back. So we're looking at question 13. Before we start reading this, let's take a look at what's going on in here. Now it seems like we have two triangles that are adjacent to each other with two right angle triangles, and there's an unknown letter x here. And I do see because this will all be split attention, meaning whatever's written here is probably on the diagram already. So in terms of getting right down to the question, we're seeing that we're going to be using trigonometry. Okay, so that tells me I want to be going to page 16 of my log tables, where all my trigonometry is. Okay, and for right angle triangles, in Junior Cert, we really just need to be looking at the bottom because we're dealing with right angle triangles. So we've got our sine, cos and tan functions, and we have our Pythagoras theorem. Okay. So we're going to use any of those three to work out the value of x and give your answer correct to the nearest whole number. Fine. So what angle is this roof here coming up at from the horizontal? This question. But straight away we feel like we just can't get it, because if we look around this triangle, we know that it's a right angle triangle. We know its adjacent is 2 meters, but that's it. We don't know h. In terms of this triangle, we don't know h. So what we're going to have to do is a bit of angle chasing, or at least we're going to have to broaden our horizons and think, can we use a stepping stone value, like if we knew h? So that takes our focus over to the left hand side triangle, where at least we have enough information. We have an angle, we have a side, and we have an ungiven side, and that's enough. So in here I want to be thinking of using either sine, cos or tan. I'll have to put it up here. I'll have to be thinking about using either sine, cos or tan. Which one is it that uses the opposite my reference angle and adjacent to my reference angle? And we can see where these meet anyway. We know that this tells us it's tan, and that this tells us as well with the relative a and b. So in other words, if you have two of the shorter sides that meet at right angles, you use tan. So let's go ahead and write that down. The tan of 20 degrees, and then we'll write down what it's worth. It's worth h over 11.8. Okay, so to isolate h using algebra, we multiply across by 11.8. Okay, so let's just cross it out here and write it up here. Okay, now we'll go to our calculator and calculate this. So I'm in a different mode now. I want to switch back to computation mode. Okay, and I'll go ahead now and key this in, which is 11.8 times tan. I don't need a multiplication symbol. Oh, I've got a load of tans there now. Sorry, there's something slow on my computer. It's already recording a video, so once came all the way back. Let's slow things down now. Tan. Okay, and 20 degrees, 20. Close the bracket and we'll evaluate that. Okay, now unfortunately that's a real number, so I can never write it down perfectly accurately, but I'll write it down to several figures. 2948. Okay, and that'll do me fine, because I'll be able to anyway, remember they only want a whole number on this, so 4 figures here is more than enough precision as we go through the problem. So this now becomes this value, and again, if we're figuring out whether to use sine, cos or tan, it'll be tan, because just like we said before, where two of the shorter sides meet at a right angle, we're using tan. So we'll write down now that the tan of x is equal to h, which is 4.2948 about, over 2. Okay, and we want to do an inverse tan. So x inverse tan of this side leaves x, and inverse tan of this side. Isn't it like the tan comes over and turns into inverse tan? So we've inverse tan of 4.2948 over 2, and we'll see what the calculator does for us now when we key that in. Now I could use answer, but I think it's a very dangerous thing to do. I could also just store this h value. Now there's no h letter, but I can store it to any of these letters. I'll store it to A. Okay, that will allow me, when I do my inverse tan, not to have to key in those numbers all again. Okay, I go into my fraction bar and I can say recall A, or alpha A, which is my 4.2948. It's actually a bit more precise than that because it's the entire precision all over 2. Okay, and come out from under the denominator and close my argument is the number going into inverse tan. I have a little guess first. Should we expect to be bigger than 50, bigger than 45 for sure. We're expecting 60, 70, 80, 90, 70 or 80 degrees is what we're expecting. So it's all a good idea to do that, and 65 degrees, fine. Okay, so x equals 6, and we want to round that. Well, rounding that is very easy, 65 degrees. Okay, that's it. As always, we'll see you in the next one. A bit slower getting out of these things.